In this video, we're going to follow up with some of the ideas presented in the last video. So we'll look at some applications of some of the properties of sets, how you can use Venn diagrams to solve some survey problems. And we'll touch a little bit into probability and go a little further into that in a later video. So let's look at the first thing I have here. We're letting U equal to the set of numbers 1 through 10. The set A consists of the numbers 1, 2, 3, 4, 5. Set B consists of 4, 5, 6, and 7. Set C consists of the numbers 5, 9, and 10. So again, remember by definition, the universal set consists of all the components in the given discussion of sets. Okay, so numbers 1 through 10 include all the numbers or elements in the other sets. So in other words, A, B, and C are subsets of the universal set. Okay, so find each of the following. So in the first one, we have A intersect, and then we have parentheses B union C. Okay, so I write out the first set. A consists of the numbers 1, 2, 3, 4, 5. And then B union C takes all the elements in B together with all the elements in C without repetition. So that would give me the set consisting of these numbers 4, 5, 6, 7, 9, 10. And then I want the intersection of that. The only two numbers common to both of those sets is 4 and 5. Okay, so that's your solution. Okay. The set consisting of the components 4 and 5. Now number 2 states compute or find parentheses A intersect B union with A intersect C. Okay, well, if you saw the last video, you saw where these two are equal. Okay, in other words, distribution of intersection over union. So A intersect parentheses B union C is the same thing as this set right here. Okay, so if you find the intersection of A and B, find the intersection of A and C, and then take the union, you're going to get the same answer. Okay, so go ahead and pause the video and compute that out just to confirm that you do get the same set. Number 3, I have A union B, and then just in case you can't see in the video, it does have a bar over this, the A union B. So I want the complement of A union B. So remember, the complement of a set is everything in the universal set that is not in that particular set. Okay, so first I look at, okay, what is the union of A and B? So I take all the elements in A together with all the elements in B without repetition, and I get this. And now I want the complement of that. Okay, so that means I want everything in the universal set that is not contained in this set right here. So what's left from the numbers 1 through 10? Well, the numbers 8, 9, and 10. So the complement of this union is the set consisting of 8, 9, and 10. Okay. Number 4, again, if you saw the last video, we know that this is part of De Morgan's law. So the complement of A union B is the intersection of the complements. So if you compute that out, you get the same. You get the same set. Okay. So if you want a complement again, and again, just in case you can't see in the video, these are complements here. So A complement consists of everything in the universal set that is not in A. So that would be this set. B complement is everything in the universal set that is not in B. So that would give me this set right here. And then I take the intersection of those two, and the numbers common are 8, 9, and 10. Okay. There we have it. Same thing. Okay, in the next section, we're going to be looking at some Venn diagrams. So this one states, use Venn diagrams to solve the following problems. Okay, so Jane is a fan of the music of singers A and B. Okay, so A represents a famous singer, say B represents a famous singer. In her collection of 22 compact discs, she has the following. Okay, so in other words, we're going to draw a Venn diagram of this information. So we have two singers. So we draw two circles representing the singers. Okay, so this would be a universal set. And you can label this any way you want. This will be singer A, this will be singer B. And then what you want to do then, given the information, you have to fill in the regions. So basically we have three regions. One of them is the intersection of the two, A and B. Then this region right here is region A, or not region A, that it's just the region outside of the intersection. And this over here is the region outside, it's still in B, but outside the intersection. And then the region outside the circle is over here. Of course, that's the complement of that union. Okay. So we try to fill in all the regions here. So the first statement says, concerning the compact disc, 5 on which both A and B sing. Okay, so then you can put a 5 right here. 5 on which both sing. And then the next one, 8 on which A sings only. Okay, so that means that the cardinality associated with this region right here and this one right here has to add up to 8. Okay, because this already has a 5 there. Okay, so we put a 3 right here. Okay, and then 7 on which B sings only. Okay, so B sings is right here. This already has a 5. So if there's 7 where B sings, then this has to be a 2. "12 on which neither A nor B sing." So this would have to be a 12 out here. Okay. And notice, keep in mind that the total number of all these values in these regions has to add up to the total value of whatever you're looking at. In this case, 22 compact discs. So 3 plus 5 plus 2 plus 12 does give me 22. So that checks. Okay. But that's the way you would start it out to complete that. Okay, so let me delete this now. And let's go to the next one. Answer the questions. And then I have it, I reproduced it over here. This one says, from the Venn diagram, then we want to answer this. How many of our compact discs feature only A? Okay, so you can see only A is this region right here, which is labeled 3. So this would be a 3. This would be a 3. How many of our compact discs feature only B? Okay, only B, that would be this region right here, which has a value of 2. How many feature at least one of these two singers? Well, that means you have to include this 3, because that includes only A. The 5 includes both, and the 2 includes only B, but it says at least 1, so we add them up. This would be 10. Okay. Clear this. Okay, so now we have one. There's a random survey of 100 male customers who shop at Amazon.com was conducted to determine buying tendencies concerning cordless power tools from 3 companies: Black & Decker, DeWalt, and Milwaukee. The following data was collected, and then they're going to ask some questions on that. Okay, so in this case, we have 3 things we're looking at, the 3 companies, so we're going to have 3 circles. I'm going to draw them here. Okay, so I'm just going to label this D for now for DeWalt, and this one will be M for Milwaukee, and then over here this third one will be Black & Decker. Okay, so I've got my, I won't put the rectangle, but these are contained in the universal step. Okay, now when you're working this type of problem, it's always best to try to work from the inside and get all these smaller regions first. So for example, data from number 3 here has 62 bought from DeWalt. Okay, so here's DeWalt, but then we have values. We have 4 regions. This one here, this one here, this one here, this one here. So I can't fill that in. Okay, and the order these will be given might differ, but in this case, the first one is where you want to start. 11 bought from all 3. Okay, so this intersection right here is for all 3. So this is 11. Okay. 60 bought from Milwaukee. Again, I can't fill that in because, again, I don't know this region here. I don't know this one here. Okay. So we go. Let's go to the bottom. Okay. 17 bought from DeWalt and Black & Decker. Okay, here, DeWalt and Black & Decker, and that's 17. So what is that area? Okay, that's made up of 2 regions. So that means the total here has to be 17. Well, this one right here is already filled in with 11, so if these have to add up to 17, this will have to be 6. Okay. The next one, 20 bought from Black & Decker and Milwaukee. 20 bought from Black & Decker and Milwaukee. Okay, so that would be this area right here. That's the intersection of Milwaukee and Black & Decker. And 11 is already filled in right here because of the intersection of all 3. So these 2 have to add up to 20. So this should be 9. Okay, that should be 9. Okay, let's look at the next one here. 36 bought from DeWalt and Milwaukee. Okay, DeWalt and Milwaukee, so we look at the intersection of those 2. It's made up of these 2 regions. 11 is already accounted for. Okay, but it says 36 bought from DeWalt and Milwaukee. So if these 2 regions have to add up to 36, and this should be 25. Okay. Now you can fill out the rest of them. Okay, because now we want to find out DeWalt. 62 bought from DeWalt. So these 4 regions have to add up to 62. So just add these up. Okay, 25 and 11 is 36, and 6 is 42. So what does that leave for this region to get 62? This would have to be 20. Okay, In the same way, 60 bought from Milwaukee. So we add these up, 9 and 11. So this total regions have to add up to 60. So 11 and 9 is 20, and 25 is 45. So to get to 60, we need 15. So this will be 15. And then the same thing for for Black & Decker. 33 bought from Black & Decker. So this region, these 4 regions in here have to add up to 33. I already have 9 on this one, 11 here, 6 here. So that's going to give us 20, and then 26. We need 7 more to get to 33. So that would be 7. Okay. Now remember we surveyed 100. So we add up all these values, okay, in all the different regions, and we get 93. Subtract that from 100, that leaves us with 7. Okay. So there you have all the regions. Now we can answer the questions here. So, how many bought only from DeWalt? And you can see that would be the 20. This would be 20. Okay. How many bought from DeWalt and Milwaukee? There's DeWalt and Milwaukee. So that means you want the total value of the intersection between DeWalt and Milwaukee. So that's 25 and 11. So that would give us 36. C. How many bought only from DeWalt and Milwaukee and not from Black & Decker? Okay. So that means I leave out the 11 because those also bought from Black & Decker. So that would be 25. And then for letter D, how many bought from none of the 3? Well, that would be the value outside all the 3 circles, which is 7. So this is 7. Okay. If you're talking about 4 things that you're looking at, then of course you'll need 4 circles. And it gets a little bit more complicated, but the procedure is still going to be the same. You have to fill in all the different regions and make sure that when you add up the total, it corresponds to the total value of the survey, of the people surveyed, or whatever you're doing. Clear this? Okay, so then I have it over here again, so you can see it more clearly. Okay, the next short section deals with probability. So I've done some videos on probability, but just to keep it simple here, probability deals with sample spaces. So what's included in your sample space? If you're throwing a die, the die can land either 1, 2, 3, 4, 5, or 6. So the sample space for throwing the die then would consist of numbers 1 through 6. So 6 outcomes are possible. So if you throw the die, you want to know what is the probability that you get a 1? Well, 1 out of 6, right? What's the probability you throw a 2? Only one way that can happen, so it'd be 1 out of 6. A 3, again, 1 out of 6. Probability of throwing a 4, 1 out of 6. Probability of a 5, 1 out of 6. So 1 over 6 if you want, and so forth. The probability of throwing an even number when you roll the die. is 1/2, because 3 of the values are even, the 2, the 4, and the 6, so that's 3 out of the 6. Okay, so just basic probability. So use the following diagram to problem 6 to answer the following. If a person from the survey is selected at random, what is the probability that he bought from both DeWalt and Milwaukee, but not from Black & Decker? And we answered the value a while ago, but here we're dealing with probability. So there was 25. Okay, what is the probability that he bought from both DeWalt and Milwaukee, but not Black & Decker? So that would be this value right here, 25. So it's 25 and there's 100 possibilities, cases. So 25 over 100, or 1/4. We reduce it, or as a decimal, 0.25. So again, probability is given usually as a decimal or a fraction between 0 and 1. You can have a probability of 0, which means the event cannot occur. For example, if I have a die and I say, what is the probability of rolling a 7? Well, it's 0 because there's no 7 on it. Okay. So the probability could be 0. The probability could be 1. Okay. When you say the probability is 1, then that means it's certain. Okay. Probability of 0 means it's impossible. Probability of 1 means the event occurring is certain. Okay. So either a reduced fraction of 1/4, a decimal of 0.25, that's your probability. B, if a person from the survey is selected at random, what is the probability that he bought only from Black & Decker? Well, again, you look at the diagram, and that would be associated with this region right here, which is labeled 7 values. Okay. So for this one, it would be 7 over 100 as a fraction, or divide that out 0.0. Okay, so that's a little taste of probability and Venn diagrams. Hope this is helping you, and we'll follow up with some more videos, math videos, along with videos on cordless tools coming up later on. So we'll see you in the next video, and take care.